Hey guys, and welcome back to another video. In the last video, we saw um, some functions that can be used on matrices in Matlab, and in this video, we are going to see logical and relational operations that can be done in Matlab. So, Matlab has a special data type called logical. Now, it has two possible values, true and false. These are also called Boolean values. Now, the value true corresponds to the number 1 or any other non-zero number, and 0 is represented by the logical value false. So some examples are shown here. So notice the difference between the data types when using 0 and 1s and while using true or false. So here you, you see that the logical values, they take up less space when compared to um, numbers. So it's always, using logical values is better in style and it saves a lot of memory. Now, logical values may be scalars, vectors, or matrices. Here we have one example of a logical matrix. So we had already seen what logical arrays are in an earlier video. Logical values are generated by relational operators, logical operators, and logical functions. Now, relational operators compare two values of the same data type and um, returns as a logical value. Now, logical operators combine multiple logical values into a single logical value, and we have logical functions which returns a logical value. Now let's see these operators and functions in detail. Now these are the relational operators in MATLAB. Now um, recall that an arithmetic operator produce a numerical value. Now relational operators, they produce logical values instead of numbers. So these are some logical operators that we use in MATLAB, and make sure you understand the difference between the assignment operator. This single equal sign, this is the assignment operator, and this here is the equality operator. The assignment operator assigns a value to a variable, while the equality operator compares two values for equality. So here, when I run this code here, the first command, it checks whether 5 is less than 2. Since 5 is not less than 2, MATLAB returns as the logical value 0. Now, since this command over here, since this is true, MATLAB returns as the answer 1. And here, MATLAB checks whether 5 is equal to 2. Since 5 is not equal to 2, we get the answer 0. Now here, in this command, MATLAB assigns the value 7 to the variable here, and in the next line MATLAB checks whether the variable is equal to 2. So since it's not equal to 2, the value inside the variable sum underscore num is not equal to 2. MATLAB returns as the answer 0. Now, when relational operators are used on arrays, the relational operator is applied element by element and produces a logical array with the same dimensions as the original operands or original array. So when I run this here, in in the first line in the code, it checks whether each element in the first array is less than the corresponding elements in the second array, and it returns a logical array of true or false values of zeros and ones, where ones represent true and zeros represent false. And here we are comparing these two strings based on their ASCII values. Since the ASCII value of C is greater than A, we have the first element 1. Since B is equal to B, here we have on both sides we have the same character. Now the third character C is not less than A, so we have 0 here, and q. Since q is greater than d, we have 1 here. Now, similarly, we can compare two logical arrays and also matrices. Now, here in the last command, I have an array of size 1 by 4, and here I have an array of size 1 by 2. So if I run this, MATLAB will produce an error since the both operands or both arrays must have the same dimensions. If they are in different dimensions, MATLAB will show an error. So now, when used with character arrays, relational operators compare the character based on their ASCII value, like we had seen here in this case. So comparing strings, which are nothing but arrays of characters with relational operator, is a very bad idea. So instead of so here in this case, uh, now when I run the first command, it works, but it's a bad idea since this produces an array of 5 logical true or false values. Now, when I run the second command, um, MATLAB gives me an error. This line over here, this produces an error since the strings are not of the same size. Now, this is the right way. Now, this is the right way to compare strings. We use the strcmp function to compare two strings. So when I run this command here, see, it returns me a single true or false value after comparing both strings based on their size and ASCII values. Now, if one operand is a scalar and the other an array, the scalar is compared with every element of the array. For example, here, in this case, MATLAB checks whether each and every element in this vector is less than 5. And here, in this case, MATLAB checks whether the ASCII value of every element of each and every element in this string matches with the ASCII value of the character I have given here. So when I run this, MATLAB returns to me logical arrays with the corresponding true or false values. Now, let's look at logical operator. A logical operator has logical values as operands and produces a single logical true or false value. So these are MATLAB's logical operators. Now, the AND operator, both AND operators, they return true only if both values are true. The OR operators, they return true if either value is true. And we have the logical NOT operator, which returns the value true if the condition is false, and if the condition is false, then the logical NOT operator returns the answer true. Now, the XOR function returns true when both values A and B are different. So consider this example over here. When I run this, it first asks me for a value of x. So I enter it, and here the second line, it checks whether x is less than greater than or equal to 0 and x is less than or equal to 10. So it returns us the answer 1. In the third line, it checks whether x is less than 0 or x is greater than 10. Since x is neither less than 0 nor greater than 10, this will MATLAB will return the answer false. Now here we have the XOR operator. Now if you look here, the first command, it's true. The first relation, this is true since it is greater than 0, and the second relation is also true since it is it is less than 10. So since both these inputs are true, XOR returns us the answer 0. For XOR to return us the answer 1, both uh, both these inputs, they must be false. So if I run this command over here again and type say -1, no, that will not work. So let's say if I change this here to this and run this code again. See, here in this case, 8 is not less than 0. So the first input is false and the second input is true. Since both values are different, XOR will return the answer 1. So now, not of true will return as the answer false, and negating the value false, it returns as the answer 1. Now, the shortcut operators. These are the shortcut logical operators in Matlab. So, when should you use the shortcut operators and when should you use the non-shortcut operators? We must always use the shortcut operators when comparing single logical values. That is, when we are comparing scalars, when we are comparing two numbers, etc. Now, when we have an array or some or a matrix or something like that, we must always use the non-shortcut operator since that will evaluate the answer element by element. Now, logical operators, they have a lower operator precedence than arithmetic and relational operators. However, always use parentheses to help make the complex logical expressions easier to read. Now, we had already seen implicit expansion in MATLAB. Now, relational operators and logical variables follow the same expansion rules as any array in MATLAB. In the same way that you can, for example, subtract a vector from every row or column of a matrix, you can also compare each row or column of a matrix to a vector. Now let's look at some logical functions in MATLAB. Now, a logical function is a function that returns a logical value. Some examples of built-in logical functions include the any function. So when I run this here, the first command, it creates a vector of 10 elements which contains elements between 1 and 10, and this relation, it checks whether the elements in this vector v is greater than 5, and any function is used to determine if any of the elements of the array are non-zero or logically true. So it acts as a natural extension of logical OR operator. So instead of doing logical OR operators between every element in this array, in this logical array, we could just write we could just use the any function which returns us the answer. Now we have the logical now we have the uh, logical function all. All function in MATLAB is used to test if all elements of an array are non-zero or logically true. Now this is essentially an extension of the logical AND operator. So this all function here is performing logical AND operator and operation between the elements of the logical array sum underscore rel. So any function is the natural extension of logical or operation, and all function is the extension of the logical and operation. Now, both any and all functions evaluates matrices in a column-wise manner, like we had seen in case of functions like min, max, etc. Now we have some other logical functions in uh, Matlab. So when I run this, the is numeric function returns true if the input matrix or the input array is of numeric data type. Is char returns true if the input character array, if the input is a character array or a string, and the is logical function returns true if the input array is a logical array or is a logical array. Now we have the n and set function. The n and set function in MATLAB is used to count the number of zero elements in an array. So when I run this, it returns n and that's n and z returns the number of non-zero elements in array. So the number of non-zero elements in this logical array is 1, 2, 3, 4. So n set counts the number of non-zero elements in an array for us. Then we have the find function. We use the find function to find the indices of the true values in a logical vector. The find function is used to locate and return the indices of non-zero elements or elements that satisfy a specific condition within an array. So this command over here, this line over here, it returns us a vector of indices whose values had been 1. Now this command over here is used to find the first or last n true values in a logical. We can find uh, first or last n true values in a logical vector by providing optional extra arguments to find. So here I have input the um, relational array, the logical array, the number of elements that I need to print, and the direction in which I want my function, my find function to find the indices. So instead of searching from first to last, this command over here, it search it searches for true elements and their indices from the end of the array to the starting of the array, and it returns the last 5 elements of the array. So if I change the value of say some real to say 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and run this here again and run this code again. So here, as you can see, the first command, it returns the array of indices which has the elements 1, and this command over here, it only returns the last 5 elements in this array. So we can find the first or last n true values in a logical vector by providing optional extra arguments to find. And this is the syntax. So first you enter the array name, then the number of elements that you need to print, and the direction in which you want the find function to search for the indices of the true values in the array. Now that's it. In this video, we saw what logical operators are. We saw relational operations and some logical functions. In the next video, we will be seeing some plotting functions in MATLAB. Now, thanks for watching. See you guys in the next video.